So hello everyone, welcome back to the channel. And today is 21-day challenge, like today's the last day. And in today's video, we're gonna solving a problem called matrix problem. And what the problem is that we are given an particular square matrix, and we have to rotate it by a 90-degree clockwise. So what we have to do, we must rotate the matrix in a place, and we are not allowed to use some extra space. So let's understand the problem first. So what we have given an n cross n matrix. Supposedly this is 3 cross 3 matrix, and our task is to rotate the matrix 90-degree clockwise. And supposedly if our input matrix is 1 2 3 4 5 6 7 8 9, and after rotating the clockwise, the output, how should the output look like? It should look like 7 4 1 8 5 2 and 9 6 3. So we must do it without using any extra metrics. So what we have to do, let's not jump directly to the code directly. First, let's observe what's a pattern. And if we look carefully, the rotation can be broken into two simple steps. Suppose if we transpose of the matrix and reverse of each row. So we have to transpose the matrix and reverse of the each row. Let me explain how this works. So in transpose, we are converting rows into columns. That means the element position is I and j. Supposedly as zero, like 0 and 0, it moves to j and I. It will move to the other position. Supposedly 1 and 2, it will move to 2 and 1. Like the 4 from here will move to the here, like the this position where the 2 is at. So supposedly if we have 1 2 3 4 5 6 7 8 9, then if we after transport, it will be like 1 4 7 2 5 8 3 6 9. So 3 will move to here, 6 will move to here, 9 will remain here. So important detail that we only swap the element above the diagonal. That means j start from I plus 1. So this avoid the double swapping. Now the step 2, what we have to do, reverse each row. So what we have to do now, we reverse each row of the transpose matrix. So after transpose, what we got, 1 4 7 2 5 8 3 6 9. Then we have to reverse that particular row, uh, like 1 like 147 to 741, then 2582 852 93692 963. So and that will give us exactly what we need, the exact 90-degree of the rotated matrix. So what we have to do is transpose that matrix and reverse the row. That will give a 90-degree of that particular. So if we see the code, what we are doing, we are making the two things. We are transposing the matrix and we are reversing the each row. So it will, if we take the complexity of that particular transpose, it will O of n square, and row reversal is also O of n square. So time complexity is O of n square, and space complexity in that particular case is O of 1, because we did everything in place. So it's just O of 1, and it doesn't take any extra matrix or extra row, extra space. If supposedly if we just dry run that particular, we have given this particular matrix to the rotate matrix function, and when it goes to the rotate matrix function, it just print the size of the matrix, and we are just getting inside the matrix. And what we are doing, we are swapping the when we are just in the transpose function, in the transpose step, we are just swapping the matrix I at j position to j and I position. Or supposedly we are swapping 0 1 to 1 0, swapping 0 2 to 2 0, swapping 1 2 to 2 1, similarly like below. And after that, what we are doing, we are giving reversing the each row. So in that particular case, we are just checking if the left is greater than right, and if in that, we are just swapping the i's left to the i's right, and then incrementing the left and incrementing the right. So what it means that like row 1 would be 741 852 963, similarly, and after that we're just returning the matrix again to the particular function. Let's also run this code and just check if we are doing right or not. So here we can see we get 741852963. That is the 90-degree rotation of that particular, like 90-degree rotated matrix of that particular matrix that we have for here.